Okay, good. So as we already take now is the single phase transformer, and this is for the distribution according to the National Electric Code. But I have to recall the fact now Saudi Arabia is moving to the IEC standard. Okay, don't forget this very important information. And the IEC standard, we have only one voltage level for the receptacle, which is the 230. But this is what is the old system which used to be used in Saudi Arabia. Okay, and this is for single phase system. In some facilities, if we have a mall or like big facility, then we will have the three phase transformer. And for the three phase transformer, basically we have like two connections. One is the Y connection and the delta connection. Now let's start with the Y connection. So this is the connection of a three phase Y connected. Now to make this connection happen, we will bring three separate single phase transformers. So we have transformer number 1, transformer number 2, and we have transformer number 3 as well. Now each transformer will be connected separately to the distribution system. So let's assume this is transformer number 1. So this is transformer number 1. As you can see, the H1 terminal will be connected to the A capital here represents the distribution line, and the small are representing the secondary, which will be connected to your facility at the end. Now, so transformer number 1 is connected to line A, transformer 2 is connected to line B, and the third transformer will be connected to line C, and this is the neutral which comes from the distribution line. Now to make the connection at the primary, to make it Y, then the internal H2 and H2 and H2 of the three transformer will be shorted together, and then it will be connected to the neutral. Okay, now at the secondary part we have X1 and X2 and so on. As you can see, X1 of transformer number 1 is going to create the line A small. At the secondary transformer 2, X1 will create B, and X1 at transformer number 3 is going to create C. And again, since it is Y connected at the secondary, X2 and X2 and X2 of the secondary side of the three transformers will be shorted together, and they will be connected to the to the ground, because it is the grounded conductor. Okay, this is very important note. The neutral, from the utility point of view, it has to be grounded, and this is again what we call it, the grounded conductor. So grounded conductor is basically the neutral. It is another terminology used to represent the neutral. Okay, now the three lines A small, B small, and C small, which will be connected also to your facility, will be called the ungrounded conductor. Now in this transformer, we can see that the voltage levels, we have two voltage levels. Now we have the line to line voltage, and we have a phase to neutral voltage. Now here the voltage will be 208. Okay, this is 208. Sorry, because I'm using the mouse, so it doesn't look nice, but at the end this is the 208 between any line to line. However, when we are using the voltage between live and the neutral, is going to be what? Is going to be 120. Using like typing, it will be much better. Okay, very good. So this is what we have if we have YY connection, and at the end we can find that we have two voltage level at the secondary part of the transformer. So let's move to the second connection, which is the delta. And in delta we have to be very careful, because in the delta distribution transformer it will be a little bit different than what you took already in circuit 2.